Okay, I think we're ready to go. Thank you again for joining today's webinar, Feeder Protection for Industrial Power Distribution Systems with the M7651A DPAC. Before I introduce our speakers, I'd like to cover a couple of housekeeping topics. Today's webinar is being recorded. We also invite your comments and questions. Please look at the Q&A chat box on your screen. If you have a question for the speakers at any point, just type it in there and we will either pose it to them at that time or hold it for the discussion portion at the end of the event. Today's presenters are Jayant Yogaratam, Senior Application Engineer, Drew Patel, Senior Product Manager, and Pedro Romero, Business Development, Sales, and Application Manager. In this webinar, we're going to discuss how the M7651A DPAC protection, automation, and control system for power distribution applications will help address industrial power distribution system challenges. Jayant, do you mind going to the next slide? A little bit about the Protection and Control Business Unit, which is part of the Grid Automation segment within Hubbell's Utility Solutions Group. Beckwith Electric was acquired by Hubbell in December of 2020 and provides protection relays for generator, transformer, feeder, and intertie, as well as motor bus transfer. They also provide distribution controls for tap changers, regulators, and capacitor banks, as well as engineering services to help customers get their project up and running and ensure its success. Electro Industries joined Hubbell just last year in May of 2023, bringing power quality meters, revenue meters, sub-metering, and energy billing and power quality analytics. Jayant, let's get started. The floor is yours.
Thank you very much, Chris. Good morning, everyone. Okay, let me start with the agenda, and after that, we will proceed with the discussion. So during these 1 hour discussions, we will be discussing about overall power system at a high level, from generation to power consumptions. We will be talking about the different voltage level used at the different applications and the reason for having those levels of voltage at those applications. And also we will be talking about feeders and different type of application with the feeders. And in addition, we will be talking about arc flash mitigation, and arc flash detection method. And second part of the session, we will be talking about M7651A DPAC protection automation control system. Is a one-box solution, and we wanted to introduce the challenges faced by the industrial power system application, how M7651A can be accommodated to resolve those challenges faced by the industries. So as a presenters introduced by Chris, that's Jayant Yogaratam, and Drew Patel and Pedro are the other speakers joining this conversation and also in the presentation. Before we start into the contents, we will have a safety moment. October is a fire prevention safety month. October is the month weather starts to get chiller and everyone turns on their furnaces. So make sure the fire alarms and smoke detectors are healthy and in active status. And be aware of the fire alarm and its sound. And whenever you hear the sound of the fire alarm, make sure you evacuate the place and call 911 for help. Make sure that you test the fire alarm and the beeping sound, and they are all live and active. And if there is a requirement, replace the batteries. And if your alarm system are older than 10 years, it's time to replace them. So that's about the safety moment, and we'll start the contents. So overall, when it comes to the power system, it can be divided into 3 sessions: generation, transmission, and distribution. The power generation is done at 18 kV to 24 kV voltage level. This is the typical voltage generation used by the bulk generator systems in the North America. When it comes to the transmission system, the voltage level will be stepped up to 138 kV to 765 kV level using the transmission substation. And as we all know, this is being done in order to reduce the losses taking place during the transmission along the transmission line. At the same time, this will help us to reduce the cross-section of the conductors which have been used to carry the power. When it comes to the consumer or end user end, again, the distribution substation come into the role. Those substations have the step-down transformers, which will step down the voltage at different levels. It can vary from 2 kV to 34.5 kV level, or in some instance, we might go up to 66 kV as well. And when it comes to the residential application, we will be seeing along the road pad mount transformers as well as pole mounted transformers, which further step down the voltage to 120 to 108 volts application, which are connected to the residential loads. So this particular table shows us typical voltage level used in the power system. This list is obtained from one of the IEEE publications. So depending on the magnitude of the voltage, we can divide this into 3 categories: low, medium, and a high. Any voltage up to 1000 volts are categorized as low voltage. From 1000 volts to 69 kilovolts falls under the medium voltage category. Anything above 69 kV are tagged as high voltage. Let's look at the loads and what are the protection devices used typically in this kind of low, medium voltage levels. When it comes to the low voltage application, the loads are typically service loads, such as fire system, security system, etc. Motor control center loads, low voltage motors, light load, receptacle loads, and HVAC load applications. The protections are provided for the circuit using the fuses, MCBs, and MCCBs. When it comes to the medium voltage circuits, typically those circuits are protected using the circuit breakers and dedicated protection devices. If it is a transformer, there will be a transformer protection relay or motor protection relay or feeder protection relays are there to provide the intelligent decision making based on the power system conditions. And the disconnecting devices, breakers, AR circuit breakers are commonly used. But at some instance, the short circuit protection can be provided using the fuses as well. When it comes to the 34 kV, 69 kV voltage level, those voltage level are more or less involved with the substation level. Let's look at a simple power distribution of an industrial plant. This is a single line diagram obtained from a petrochemical industry. If you look at this connection, there are 2 feeders feeding from the utility to 2 transformers. They call it as a main transformers. These both transformers step down the voltage from 13.8 kV to 4.16 kV level. And along the distribution system, if you go further down, we will be able to see several transformers are stepping down to further lower level up to 480 volts and also 120 to 140 volt system. Let's look at what are the type of loads connected at each and every bus. When you look at the 4.16 kV level, you see the large induction synchronous motors. We know that in a industrial application, medium voltage motors are very common because medium voltage motors are used for the high horsepower application. Those motors are connected in this particular case at 4.16 kV level. And further, there's a transformer step down to 480 volts, and the 480 volts bus connected to 480 volts loads, which also could be a low voltage motors. And further, the 480 voltage step down to 240 volts or maybe below 120 volts to provide protection, provide a supply to the lightning load, receptacle loads, any other auxiliary roles you find in the plant. So in certain cases, some heavy industries are directly connected to the transmission line without going through the distribution substations. The purpose of having heavy industries connected to the transmission line, one is an efficient, they can prevent some kind of losses. Also, they will get a good pricing when it comes to the energy prices. The heavy industries, typically we name them as steel mills, aluminum smelting plants, chemical plants, oil refineries, large manufacturing facilities such as automobile facilities, etc. when you look at this power distribution, at least minimum two main feeds are connecting from the utility. And in some instance, this can be more than two as well. This provides reliability and help the operation to perform maintenance without causing any power outages. So this is like a redundant supply, and also they operate most of the cases in parallel, where the tiebreaker is open. Now, if we look at this application, we get two transformers coming in, and that step down, the 110 kV is the primary voltage, step down to 33 kV. And further, there's a two feeds coming in and interconnected with the breaker, which always kept open state. So in order to reduce the short circuit fault current level. And each and every feeder down the line, if you look, each and every feeders in this particular application, they have 6 kV voltage bus, 0.4 kV voltage bus, which is a 480 volt system. So each and every buses are fed with two feeders. And this is basically every bus is powered up using the two feeders, which is leaving the tiebreaker open. This will improve the reliability of the supply in an event of failure of one feeder. So this is another single line diagram from another plant, and technically I took this one in order to explain what type of protections are being applied depending on the devices connected in the devices connected to the bus. So the main supply is coming from 69 kV, that step down to 13.8 kV level. And further, we will be able to see you have a 2.4 kV bus as well as 4.1 kV level. And also you get the low voltage buses as well in order to feed the low voltage motors and other auxiliary applications. So when it comes to the protection, there are motors. Motors need to be protected by motor protection relays because motors require dedicated protections, so that will be provided by the motor protection relays. When it comes to the feeders, the feeder protection relays are being used to provide protection for the feeders, technical cables and the conductors. And when it comes to the transformers and the bus, those devices require differential protection. Then the bus differential and the transformer differential protections are being used. Used to provide the required protection for those devices. Let's look at the feeder. What is feeder? Feeders are the conductors and cables connecting the distribution substation and to the primary circuits or to the load. When it comes to the basic feeder protection, the main current-related protections are 50-51 function, which is 50 is the instantaneous overcurrent element and 51 is the time inverse overcurrent element. However, there are other protection functions which works on the current signals as well as the voltage signal as shown in this diagram. The voltage, when it comes to the protection elements, works on voltage signal, which are under voltage, over voltage, and the synchro check functions, and the power and the frequency element works with voltage and current signals. And when the feeder relays can be used to fulfill certain specific applications, which commonly found in the industrial and utility environment. The feeder protection relay can be simply used for the overcurrent protection for the radial feeders or mesh feeders or ring feeders. You can provide the feeder protection relay can provide overcurrent protection, as well as it can do arc flash detection, load shedding, under frequency load shedding, under voltage or load shedding, and also it can perform auto reclosing, zone sequence coordinations, and also reclosing with saving the fuse and blowing the fuse, and also zone selecting interlock mechanism, cold load pickup, etc. There are certain dedicated function the feeder relay in addition to the protection element, it also can be used to fulfill certain application requirements. When it comes to the feeder protection is a type of protection used in a distribution circuit to prevent damages to equipment or personnel to minimize power outages. And it ensures that the power grid continues to supply the energy and prevent fault from spreading out throughout the healthy circuit. The main requirement of the feeder protections are that during the short circuit, the circuit breaker closest to the fault should open and clear the fault. And any breakers involved with the circuit which are not falling into the fault zone should remain closed and continue to provide the supply. This is called selectivity. If the breaker nearest to the fault failed to open, the backup protection is provided by the upstream circuit breaker. The feeder protection improves the safety and the reliability of the distribution feeding system by providing primary backup protection. So I have mentioned two standards which you might be able to use as a reference when you are thinking about feeder protections. IEEE 242 bulk book is one of the reference we could use for the coordination of industrial and commercial power system application, and the IEEE C32.230 provide the protective relay application to distribution line. So we are all familiar with the time over current protection. Technically, it is defined by the IEEE standard C37.112. This is the time inverse curve, and the mathematical model is being provided by the standards. And by selecting the proper slope constants, alpha and beta, the curves can be categorized. Either it could be a standard inverse curve, definite time curve, or very inverse or extremely inverse. So the selection of curve can be adjusted based on the selection of the constants. However, now the protection relays already have the built-in table, so it helps the user to just to go and select the curve because it's already built in the mathematical model already been embedded in the code. So when it comes to the time over current curve setting, there are two parameters need to be set. One is the pickup setting. When it comes to the time over current element, time over current phase time over current element, the pickup is set roughly around 1.3 to 1 times of the maximum feeder load. So in addition to that, when it comes to the ground over current or neutral time over current elements, rule of thumb to set 25 to 30% of the load current. Or we have to make sure that whatever the pickup is being set, it should be able to override the maximum unbalanced current seen by the system during the normal operation. And the second parameter, what we talk about, the time dial. Changing the time dial, it will move the curve vertically upwards and downwards. So the time dials are being selected based on the time coordination with closest upstream device and the closest downstream device. So this time dial will help to discriminate the one device over the others. So it will allow the relay to trip on the fault which is fall within that zone. The other factor, another application with the feeder relay is the arc flash protection. What is arc flash? Arc flash is a type of electrical explosion or discharge that results from a connection through an AR to ground or another voltage phase in the electrical system. For an example, power conductor coming into contact with a metal connected to the ground, that will create an arc flash. The arc will create light energy, excessive heat energy, as well as the pressure. The temperature at the source can go up to 20,000 centigrades. It is almost 4 times of the temperature of the sun, surface of the sun. When it comes to the arc flash, there are a few parameters we need to understand. One is the arc flash boundary. Arc flash boundary is the term used to describe a distance at which a person without a personal protective equipment may get into a second-degree burn if the arc flash occurs. The second-degree burn from the experiment they have found if a point has 1.2 if a point has an incident energy of 1.2 cal per centimeter squared, a human being can get exposed to second-degree burn. Then now the question comes, what is incident energy? Incident energy is the quantity used to measure the strength of the arc flash. So it is a function, this has been calculated based on the bolted fault current at the source, and also time taken to clear that fault, and also distance from the fault, distance from the source. Those are the three parameters used in the calculation of incident energy. So if you are really interested on finding the exact equation, I can tell you two reference. One is the NFPA 70 standard document, National Fire Protection Association standard document. And also you may refer the IEEE 1584 standard, which gives you all the equation at different voltage and how to calculate the incident energy, arc flash boundary, etc. So how does the arc flash happens? There are a few reasons we can name it, but it can be more than that, whatever I have listed here. Improper work procedure, dropping of the metallic piece in an energized switch gear, or it could be a worn or loose in connections, or gaps in the insulation, which will bring down the flashover voltage that can create an arc flash, and improper installation of the parts, building of dust and the moisture, which can provide the short path for that arcing to happen, or flipping of the polarities of the conductor, etc., aging of the equipment, etc. How that can affect the arc flash is basically like what I said before. It brings a tremendous amount of heat energy, which can cause severe burns. Also, it can vaporize the metal. People can inhale the toxic gas and get internal damages to the internal body damages, or in some cases can cause death or ruptures, physical trauma, hearing damages, etc. So there are some regulations has been established. There are certain standards that have been published in order to mitigate the arc flash. So the providing arc flash protection is mandatory, is not a choice now. So Article 130.5 of NFPA 70E states that employers are required to conduct an arc flash risk assessment for the workplace of electrical equipment. What that says is every 5 years, um, every industry has to perform arc flash studies and label their equipment with the arc flash boundary, incident energy, and the PPV requirements, so that the operator can follow when they are doing any maintenance or any operation with that gears. And also, National Electric Code has traditionally addressed the proper installation techniques, intention about prevention of fire, prevention of fire, uh, etc. And now they have come up with the contains related to the arc flash, protect from arc flash hazard. And also IEEE 1584 and NAFTA 70 standards talks in details about how we could do the calculation and come up with the labeling. Let's take us to a situation where what type of protection we need to provide. During the normal operation condition, the switch gear must be provided with a mechanism to detect the arc flash and operate the upstream switching devices to de-energize the feeder. So that what that means is there are devices comes usually M7651A has the capability to accommodate 4 optical sensors, so that optical sensor transceivers, which you can connect 4 position sensors or 4 loop sensors to detect the arc flash. When it sees an arc flash, it will send a signal to the upstream breakers to trip and disconnect the power to the arc. And the second one is to reduce the incident energy at the arc flash boundary level and the working distance. Let's see how we can do that. So we all know in the substation environment, the operators do maintenance activities such as metering, reading operations, and breaker operation, cleaning, etc. But when they are doing this kind of activity, there's a chance during the working time, there is a chance the arc flash can create and the person can put himself under danger. So this can be minimized by adjusting the set point group so that we can come up with a setting which will expedite the tripping time when the fault comes, so that will reduce the incident energy at the source, so that by having a proper PPE arrangement, the operator can get protected. So if a device have multiple sources, if a device has the capability to work with multiple set point group, you can have a second group for a maintenance with a sensitive protection and a fast tripping time, which can be used, which can be enabled during the maintenance and provide arc flash mitigation to the operator. And this table is got from the IEEE 1584 standard, and there are categories of arc flash level based on the incident energy. Anything greater than 20, it is recommended to do area communication means to perform the operations. So this is the comparison of arc flash incident energy when the normal mode as well as the maintenance mode. During the normal mode, you could see this particular application, 50p element was not enabled. Only 51 element was enabled, and we can find here the false clearing time was 819 millisecond, and the arc flash incident energy was about 27 calorie centimeter square. And once we put onto the maintenance mode and the engineer enabled the 50p element, and with the 0 time delay, the fault clearing time went down to 83 millisecond, and the incident energy went down to 2.73. So this is what expected from this application. They expected to happen. So during the maintenance mode, we wanted to switch a group and provide the arc flash mitigation. The other functionality I want to talk about, the under frequency load shedding. So the under frequency load sharing, technically, it comes to manage the load which is available, to manage the load, whatever manage the load with the available generation. So what happens is, in a situation when when generation is not adequate enough to support the required load, in that case, the utilities or even any applications are required to cut down some of the load. That is called load shedding. The under frequency element can be used to perform this load shedding functionality. When the load is higher than the generation, it brings the frequency down below 60 hertz. So the under frequency element can be set up in such a manner to pick up on under frequency value, operate an output contact, and disconnect the circuits from the system. By that way, we could reduce the load and try to manage the available generation with reduction of the load. And this is the roller coaster way of representing. It is self-explanatory. When the demand is equal to generation, the frequencies stay at 60 hertz at stable. When there is a deficiency on the generation due to the drop of generation or adding of load, sudden load, which will bring the frequency down. But by doing the load shedding, the frequency can be brought up back, and when it and brought to a stability. And if you have multiple levels of under frequency element, you may be able to do a multi-stage under frequency element. And if the load shedding is not done fast enough or adequately, there is a point beyond the system is unrecoverable. So when we look at this particular curve, there are two curves here, one and the curve number 2. we always expect to follow the curve number 1 after the four stage load shedding. The frequency is expected to get stabilized and pick up and stabilize at the normal frequency. However, if the load shedding is not at the correct speed, and also if the load shedding is not done in a and also the generation is started to further start to get reduced, and the load started to increase. Sometime the load shedding may not bring the system back. The other one I like to emphasize on the under voltage load shedding, which basically works in a simple principle. There are loads which consume reactive power. When the reactive power need to be fed by the generating sources. So if the reactive power is not sufficient to feed the load, it will bring down the voltage of the bus or the point of common coupling. So only way what we can do, if the generators cannot inject more reactive power to the bus, then only the way we can bring the voltage back to normal by load shedding. And that is, in this particular case, we will be using the under voltage load shedding with the supervision of a reactive power element. So this is also another under voltage load shedding examples here. This is one of the examples seen in certain cases. What can happen is industrial facilities consumes a large amount of reactive power in order to power up the high inertia motors. So in certain cases, uh, if there is if there are some loads which are directly connected to the transmission line, if the due to some transmission fault, if the transmission line is after clearing the fault, it takes some time to stabilize its voltage, so system voltage. So during that time, if we are trying to energize certain loads which can bring the voltage further down, so in that case, only remedy is to shred some of the load, and in order to bring this voltage back in normal. The other application I wanted to talk about, the zone interlocking. This is very straightforward. Let's study this circuitry. There is a feeder feeding the bus, and there are 4 radial feeders feeding the load. So we have a protection device at the feeder feeding the load, which is called source relay, and we will identify the feeder feeding the load as the load feeder. So if there is a fault at the load side, then both these relays, the relay at the feeder, relay at the source, and the relay at the radial feeder will see that. So we need to discriminate here, because we wanted to keep the power maximum as possible to the loads. Only we wanted to remove the faulty conductor, faulty feeder. So what happens is, in this case, the radial feeder will send a signal to block the protection operation of the source feeder, and that is called, and in that way the fault will be taken care by the feeder connected to the radial feeder. That is called zone interlocking. Conversely, if there is a fault at the bus, then that fault will be only seen by the source feeder relay, and immediately trips and isolate the fault. This has an advantage. Here the relays can act fast on the fault and clear the fault, and also it will reduce the arc flash energy levels. Let's talk a little bit of the reclosing. We all know the reclosing operation. So reclose is typically in the distribution system. In the distribution system, the faults are temporary. So the faults can be caused by weather or animal or any vegetation. So what can happen is, when there is a fault, the recloser will trip and isolate the fault area. But next moment, the fault will get cleared, then the recloser will start closing and reestablish the power back to the users. But if there is a permanent fault, yes, it will go and time out and complete the whole sequence of reclosing operations, and finally it will get on to the lockout mode. When it comes to the when you see a couple of auto reclosers working together in series, then we need to understand how this works. When two reclosers are used in series as shown in this diagram, the coordination the coordination advances the reclosing sequence for the upstream recloser when a downstream recloser trips. The station recloser sends the fault current pickup and a subsequent dropout when the downstream recloser clears the fault. When the station recloser sends the downstream recloser trip and station recloser skip to a next shot. So this arrangement will help. So in this case, we are seeing the fault is downstream of the line recloser and it operates and isolate only the faulty area, which faulty area, and keep on energizing the customers who are not covered under fault zone. So that's what I am just wanted to talk in this first half an hour, and I will introduce Drew to take control of the next half an hour, and he will be going to go through the M7651A product and its applications. Drew?
Thank you. All right, let me share the screen here.
While Drew brings his screen up, does anybody have any questions? Again, if you do, at the bottom of your screen, you will see a Q&A box. Please click on that and you can pose your question in there. I'll either ask it at that time or we'll wait to the end of the session when we'll do Q&A. Thanks.
Okay, hopefully you guys. Oh, so hopefully you guys can see my screen. 51A. And it's used for power distribution applications there. And the 7679, which is our recloser. Okay. All right. So what does this?
Drew, I'm sorry. It seems your audio is lagging.
System
Maybe you want to turn your camera off.
7650 DPAC has several categories.
Drew, it's Chris. Can you hear me?
Okay.
Yeah. Turn your camera off, you please, and let's see if that helps your audio. You were lagging a little bit.
Let me know, and I'll switch to my. Yep. Can you hear me?
Yes, I can.
Okay, yeah. So yeah, the internet is a little unstable here at the moment because of the power going in and out. So if you don't hear me, do let me know, or you can call me, whatever. I'll join through my phone, and then we can continue that way as well, if needed. Okay, so the feeder protection has the 8 setting profiles and groups. It has a comprehensive I/O matrix. It has visual coordination, arc flash protection, obviously, as you saw, and we have a lot of programmable inputs and outputs, a lot of I/O graphical interface for the logic development, and comprehensive function status to see the active elements. So all in all, from a protection control standpoint, what we've tried to do with this product is make it very simple, very easy to use and program, and very easy to operate, right? So that's the ultimate goal, is to spend more time doing the calculations, making sure we're getting things right, rather than spending more time programming a relay and learning about how to program. On the monitoring side of things, it's very powerful. On the power quality side, it could do up to 63rd harmonic, including THD, TDD. Again, visualization is a key here. So we have a power quality viewer, and you could see all the events on there. You could have oscillography, data logging, sequence of events, and all kinds of recording capability that a normal digital relay, a modern digital relay would have. The other piece is it also has a front USB and an SD card port, and I'll talk more about that later. And on the communications side, we have single and dual Ethernet ports and all the protocols that a normal industrial plant would be using, like Modbus, DNP, 6150, and IC104. And then the other kicker here is that it's got embedded cybersecurity, right? So you don't need a separate gateway for this. It includes function features that allows you to be NERC compliant, and it has built-in VPN tunneling and radius, authentication management, and the 1686 password requirements also there, so you can comply to that. When we look at the functional block diagram, as you can see that we have a breaker, and then the power is reverse on the top and forward at the bottom towards the load. And we have 3-phase CTs that get attached to the relay, and then you have 2 voltage sources, one on the source side, one on the load side, and then several of the elements that are voltage elements. And then on the right side, you'll see all the other applications typically come in with this M7651A DPAC. A lot of them are standard, and others are more optional. On the back side of it, this is turned on its side now, so you could see it better. And outputs. Let me see if I can get a laser pointer. Right, so that's your standard IO, your 12-volt input power if you want to power it up with 12 volts. Or there's a power supply, but your regular power supply for low voltage DC, high voltage DC, or your regular AC supply to that. Your serial fiber, dual Ethernet, copper or fiber, could be both. And then we also have IRIG-B here. And then we have additional expanded digital inputs over here and expanded digital outputs. These are optional, right? So if you wanted more inputs and outputs, you could have them. And then at the bottom, you have your currents and voltage inputs. Now, there are certain options, right? So on the communication side of things, you could opt out for the serial port, and then you opt in for, let's say, an analog output board, right? So you can have 2 analog outputs on that card, 4 to 20 milliamps or 0 to 20 milliamps. And then also on the 232 side, you could also switch in to have a 485 if you wanted it. You could have a 232 and a 485 both, depending on which card you pick. And then at the bottom, you see there's a voltage and currents. Now you could switch that out for an optional arc flash protection, right? So when you order arc flash, it comes with the 4 arc flash sensor inputs, and then you have 4 high-speed outputs, right? These are your solid state relays and have outputs less than a millisecond. When you look at the brochure and the specs, you will notice that we have an ordering selection table or ordering guide, ordering sheet. And that goes through letter by letter, what you can pick, what's the code for that, what's standard, what's optional. So if you're interested in future, that would your brochure would be the right place where you can find this kind of information. On the dimensions, so there's 2 ways we show this as a horizontal model, and then there's a vertical model. So on the horizontal model, we have a half rack type of a form factor. And then you can also have a plate that goes on the side, and you could mount it in your standard 19-inch. Or if you wanted to put it in the enclosure, that's also possible. You just have to have the right cutout for that. And then that's a 3U high, right? And then you could also have a test switch in there if you wanted it. And so there's a hole for that in the adapter plate. Then we have a vertical model, right? So the vertical model has the same form factor as the 751 from Schweitzer. Right, so you've got the same panel cutout, so there's no need to change the cutout. Your standard designs can stay the same. And if you're looking at Beckwith relay in that case, then it'd be a swap in for that purpose. Now let's look at a little bit on the configuration of how you configure this relay, right? So we have a software called IPSCON S7600. So the 7679 and 7651A both can be used, can be programmed using this S7600 software. Very light, it doesn't have a lot of baggage. It's less than 300 megabytes in size for installation. So you can imagine it's very, very lean in terms of installation and doesn't need much requirements in terms of the computing power for your PCs. So this is a basic screen of what that looks like, right? You have your status bar at the bottom. So you could see that the unit's ready, there's a writing activity, what kind of fault type it is, and all kind of status information. You have a firmware version, serial number. So you could see all of those. So quickly running through, so you have file menu options. In communications, you have COM port, Ethernet settings, protocol configuration, security. In monitoring, you could see all of the visual tools we give you to monitor your relay, the live status of each of these things. So the list goes on, and we continuously develop more and more, and we're trying to bring more ease of use into the market to show that you don't need a PhD degree to go and configure a relay. You know, you can be just fine knowing just briefly what protection is, how to program it, knowing the syntax, understanding the concepts, and that's good enough for you to go in and start entering the settings. Then you have setup. This is where most of your settings come in. So set points is where you configure most of your settings, and configuration is where you set the relay settings, right? So if there's device specific things, you set there. And then we also give you a wizard, right? So there's a wizard that for reclosing that you can go in and program a certain function without going in individual elements and programming them one by one. Okay, and then there's utility. So we allow you to do a lot of data analysis, cybersecurity, hardware, and whatnot. But the one I wanted to mention was a data analysis because that's where you see all the records. And the BCO plot on the right side, the bottom, that's our oscillography viewer, and we'll look at it in more detail. And then on the email side, the help side, you have the manuals right there, and then your email support. And I'll talk more about what that means when you have the email support and what it really should be about, right? So when we look at the industrial power distribution systems, there's a lot of challenges, and I want to highlight some of the challenges and see how we address some of those with this relay, with this platform. So number one was a lot of the applications are individualized, right? They have a lot of electromechanical relays still in place and a combination in some areas. So there's a lot of complexity in the wiring, complexity in configuration, operation, maintenance, communication between them. So even your operation philosophies will change over time. So what we're doing is we're putting all of those in the same box, right? So one box solution has over 30 protection elements, 8 setting profile, so you could choose and has a lot of control automation monitoring solutions to reduce your complexity. So when you're upgrading from your retrofit, when you're upgrading from your electromechanical relays, then this would be an ideal solution to look at because it lays out very nicely what elements are available here. So all you'll see are voltage related elements here in this frame. You see current related elements here in this frame. There's synchrocheck, power, frequency, and other. Then there's other control side of elements, right? And then there's a reclosing, and arc flashes it's on its own. Then there's some more common set points, strip code monitoring, and if there's battery charging, you could do that. So all of the common set points are on that side. The other challenge we see is number one, when you try to connect to the relay, how do you connect it? Well, I gotta have a specialized cable. I gotta have the right drivers. I gotta have if I'm connecting through serial, I need to know which COM port it's going to be on my computer, right? What's the baud rate? What's the data bit, stop bits, parity, RTSD? So blah, 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 right? So it's a lot of this information that you have to figure out before you even, step your foot in the relay, so to speak. So the idea there is simplify that, it's a USB connection, it's a printer cable that connects right in the front, and it comes with all the drivers you need. So software is pre-populated with the drivers, so you don't need to go in and find out which COM port you have. If you're used to connecting to a serial port, then this will be a breeze. And when you open the software, when you try to connect, it automatically detects what USB device there is on the system and what's the serial number, so you can identify exactly which relay you're connecting to. The other challenge is there's a constant need to train your technicians on how to extract the event data oscillograph to retrieve settings or upload settings, right? So the feature that we provide here is through an SD card. So in the front port, you have an SD card slot. Now that can be used for loading data points, saving data points. You could have the saving of the oscillography, records, metering, data logs, right? You could clone, so you could copy settings out of this and put it in a different relay. You can update the firmware with this, and it also acts like a physical security key. So you know that you gave it to the right person, and the right person is going in and doing the job, and there's no other person who has access to it other than the person who has the SD card. Basically, that becomes your key. So we've made it really easy for you to go and do all of this. And the nice thing is we can also develop job aids with you, right? Customize it to your needs, to your operation practices, and write a one-page procedure, two-page procedure that says, here's how you go in, upload the firmware, here's how you go in and extract all the information you need. Because when the time crunch is there, when an event happens, you want to know everything as soon as possible. And this is a real fast way to go in and put this card in, extract the data, get back to the office, and start analyzing right away. And what we hear is as newer and newer generation of engineers come in, the relays seem difficult to configure, especially when settings are in tabular format and you don't know if a setting has a dependency on another setting, right? So what we've done is we've intuitively made the interface such a way that your settings are grouped in a logical way, right? So you know that the pickup value and the time dial, and the minimum response time, those are the settings that go together. Now, voltage supervision that you do, that could be a separate group, right? So we're not going to just put it one after the other and let you figure it out. We make it easy for you to go in and do that. So as you see here on the system setup, you have your system, your input, virtual input, output, user lines, file identifier, and then here's your terminal assignment, your phase rotation. Here's your CT ratios, right? Here's your CT polarity, right? So we make it very easy and logical for you to follow through. Same with, let's say, a typical 51P element, right? That's your timed overcurrent protection. You see the pickup, the curve selection, time dial, time adder, minimum response time, and electromechanical reset. And you can even see the graph and see how it's laid out, right? And then we say, okay, 51V, if you want to do the voltage control or restraint, then that's a separate category. And then you could disable it, you could select this. So it's very easy for you to follow through. And then there's inputs and outputs. I mean, the outputs and the blocking inputs are obviously laid out separately, so you can easily see which one is selected there. And this is consistent throughout all of our elements, right? So you would see the enabling over here, you'll see the outputs and the blocking inputs here, you'll see inrush restraint, and you'll see visual cues as to how to configure this. Same with metering. You'd see the currents, voltages, they're separate. The sequence component is separate. You could see the power, all three power, your inputs, your frequency, your outputs, right? So you're no longer having to shift through a table of values and try to figure out, okay, where do I have to stop looking, to find out where the phase B power is for the reactive power, for example. Okay, the overcurrent curves need to be programmed in the relay and reviewed carefully to make sure there are no errors in coordination. So what we've done is we've given you visual cues, right? So we say, okay, you program it there. Now you have an overcurrent settings screen where you can choose which curves you want, what settings you want, and now you could see it on a screen. You could see all three curves right there. And then there's a cursor. You point on the cursor, it'll tell you exactly if there's a fault of let's say two per unit. What does that look like? What does that look like in terms of operating time? The other challenge we see is you have to be very careful in reviewing the settings to avoid human errors, especially when configuring multiple elements that drive various outputs. So what we do is we give you a bird's eye view of the programmed elements and their selected outputs. So this is a function stats, right? So you know right off the bat which ones are picking up, which ones are tripped, which ones are blinking, and you'll see the inputs and output statuses right there. And then there's an IO map, right? So if this element trips, let's say the 27 element trips, I know the output number 4 is going to go off. But if the input 3 is active, I know it's going to block it, right? So it's very easy visual tool for you to see that there's no conflict. You know, if you're not selecting the same blocking input for multiple elements. And then there's a file compare, obviously, so you could see if you have a reference file and you made the changes, you can easily see, so it's highlighted for you, what those changes are. The other challenge we see is automation and logic. You know, you have to learn how to write the equation, okay, to do the logic and do customization and to be able to understand the logic. There's one person who programs it, and then if that person leaves the company, then good luck, right? You have to figure out what that means. And there's no comments or there's no so now modern relays obviously have the logical interface for you to program the customized logic that you want. And the nice thing here is you could test it. You can simulate that, hey, my output 3, my remote input 7 is going to be active. What does that actually mean in terms of the output? And I can assign all of the comments, so I know exactly which signal. So if this signal is out, then I know it's a transfer trip initiate conditions are met. So I can attach all of these comments to it. The other is the power quality side, right? So you have to know what you're feeding into your plant, because that could lead to a long-term damage to your processes. And there's a SBEMA curve that shows you where the no damage region is, and interrupting region, and a prohibited region. So we give you that information. So what we've done is we've tabularized it, we've plotted it on an ITIC curve, and when you select one of these points, it gives you a detail of what kind of event it was. And then you could also see the harmonics visually. The other nice thing is when there's a time crunch, you need data right away. How do you get that? Let's say you want to email somebody for help. You want to email us for help. When you click help and email support, it automatically gathers data logs, events, oscillographies, firmware versions, etc. All the information that our support guys need to answer your questions, right? So you could select what you want in there. It gives you oscillography too. That's the event. So when you click on the event, you could see all the data details of that event, the oscillography, the phasor plot. You could select which values for the data log, and you could see 792 days worth of data you can store, right? So you don't have to go out and extract information quite frequently. This is especially helpful when you have turnarounds, right? So for your plant turnarounds, when you're going and getting the data, this is very easy for you to get. And then you could also select different viewing windows, so you could see the frequency, apparent power, phase diagram, PQ diagram, impedance diagrams. And then we get into arc flash is when you want to avoid severe injury or even death in terms of arc flash, and you want to do breaker maintenance. So, well, we know that breaker accumulator you could do I square T, I 1.5 times T, and or IT. And then we plot that on the you have a curve for the breaker. We'll plot that. And then you also have the counters to go along with it. So you could get a better picture, a full picture of what your breaker's wear is. And you could set alarms and limits so that you can know when that alarm, when that limit has reached, and you can schedule it for your next turnaround. Arc flash, right? So we have arc flash in the 7651A. And then using 4 optical sensors, it has point sensors and loop sensors. And depending on the configuration, you could use your loop sensor for the buses. And then if there's hotspot areas, you could put the point sensors there. Just back of the relay, you could see those are the inputs for the arc flash. That's the high-speed output. And then you have your extended IO, basic IO here, Ethernet port. Just some more pictures for that. And then the high-speed outputs are obviously solid-state relays, so then you have less than 1 millisecond of output. The whole purpose for the speed is to limit the incident energy, right, on the arc flash. So there's some more information. So you could find all of this information in our data sheet when you're ordering arc flash to see what the part numbers are, what the length could be, the attenuation, and all kinds of details, how to calibrate and how to set. All of that's high. And then there's some advantages, disadvantages you see of having a loop sensor versus a point sensor. There's strict strategies on how you best optimize that. Okay, so logic is pre-built for arc flash, so you don't have to do it by yourself. And then there's the settings for the arc light. Then you could do a overcurrent supervision on different phases. And it's very simple, how you program it. And we typically keep it very sensitive because you are putting it in a darker environment. So any light that comes in, it's detected right away, and you want the highest speed possible. The other thing is cybersecurity. If you have a cybersecurity event, you could have loss of revenue, reputation damage, regulatory fines, right? And oftentimes, when somebody says let's implement cybersecurity, it's very expensive because you have to have separate cybersecurity gateways across your plant, across your communication network, right? So the way we help here is it's embedded in our relay, so you don't have to buy a separate security gateway. It's 1686 compliant, and it has features that make you NERC compliant. Right? It has a radius, it has the VPN tunneling, it's got the accountability, right? So you know who's logging in when and where. Right. So just more images of what cybersecurity entails. You have your password complexity requirements. You could choose your roles. You could assign users and give them separate permissions. You could add roles too if you wanted. And then you could disable the ports. So if you have physical ports, you could disable. If there's protocol access, you could disable if you're not using them. So that's all in all about the 7651A DPAC. If you have more questions and more information that you want, so for quotations, we have an email here, Beckwith Electric Protection Sales at Hubble.com. If you have support questions or training needs, then Beckwith Electric Support at Hubble.com is the email. And then for literature and information, that's our website, right? So the beckwithelectric.com/product/M7651A.